Hi everyone, in this video I'm going to solve Cambridge O-Level Additional Mathematics Paper 2 in a session October-November 2025 Paper 2-2. So let's start with the first question. Question number 1, the line y equals to 4x minus 3 meets the curve y equals to 3 plus 5x minus 2x square at the points A and B. Okay. Part A, find the coordinates of A and B. So A and B are basically the points of intersection of the curve and the line. The curve is a quadratic and line is the linear one, right? So we need to figure out the point of intersection of this curve and the line. Okay, so here we can say that points of intersection of curve and line. Okay, so this is my second equation and that is my first equation. Okay, now we have to substitute. This is y equals to something, y equals to something. So here we can say put equation 1 in equation 2, or we can say put equation 2 in equation 1. This is both are equal, the same. Okay, so here we can say 3 plus 5x minus 2x square equals to 4x minus 3. So basically we have to compare the two y values. This y value substitute over here, or this y value substitute over here. All right, now we have to solve for the x coordinate first, because this whole equation look like is in the variable x. Okay, so we can say minus 2x square plus 5x plus 3. I arranged it and now shift all the terms to the left. 4x becomes minus 4x, minus 3 becomes plus 3 equals to 0. So it is negative 2x square, and 5x minus 4x would be plus x, plus 3 is equals to 6. Okay, so this is my quadratic equation. Now we need to factorize this quadratic equation to find out the roots, the x values. Okay, so let me do the factorization. Here we can say minus 2 times 6 is minus 12. Now we need to find the factors of negative 12. When we add them up, it should be positive 1 equals to the midterm, right? Okay, so we can say 4 times 3 minus 3 is minus 12, and when you do 4 minus 3, that is equals to positive 1, right? Now we can easily break the midterm. So minus 2x square plus 4x minus 3x plus 6, that is equals to 0. Now we can say taking 2 common and x common. So here we have minus x plus 2, because 2 is already common, x is common, just minus x is left, and we have or if you would like to take minus 2x common, it's okay, it's fine. You can take minus 2x common or just 2x common. 2 times 2 is 4. So now if you are just taking positive number, so this bracket also stays the same. So take 3 common, so minus x is left, and 3 times 2 is 6. Now you can see the factors inside the brackets are equal. So the two factors are 2x plus 3 is one factor, and we can say minus x plus 2 is the other factor. Put this equals to 0. Okay, now we have to substitute these two factors separately equals to 0. So we can say 2x plus 3 is equals to 0, or we can say x minus x plus 2 would be equals to 0. So here we can say 2x is equals to negative 3, and the x value is negative 3 by 2. Minus x would be equals to minus 2, and you can easily cancel the my negative sign, so x should be equals to 2. So here you can say these are the two x coordinates of A and B, the point of intersection of the curve and the line. But we need to solve for the y coordinate as well, because the question says find the coordinates of the point A and B. So we need to solve for the y coordinate. Now just substitute the x value into this equation or this equation. You can solve for y. This is up to you. So I would like to substitute into the first equation, which is y equals to 4x minus 3. So here we can say put x values in equation 1, which is y equals to 4x minus 3. Let me double check my equation number 1. 4x minus 3, yes. Okay, now the first is y equals to 4, the x is negative 3 by 2 minus 3, and the other one is y equals to 4, the x value is 2 and minus 3. Okay, so we can simplify. For 2 times 1 is 2, 2 times 2 is 4, and here 2 times 3 is minus 6 and minus 3, that is minus 9, and 4 times 2 is 8, 8 take away 3, that is equals to 5. Okay, now here we can say the coordinates of points A and B are, you can take any coordinate as A and any coordinate as B, right? Okay, so let me take the first one, A, which is negative 3 by 2, and when x is negative 3 by 2, the y value is negative 9, and the b one is when x is 2, the y value is 5. So these are the coordinates of points of intersection of the line and the curve, and we have to name those coordinates a and b. Because the line and the curve meets at the point AB, we have solved for the coordinates of a and b. So this is done. Now for part B, the perpendicular bisector of line AB cuts the coordinate axis. Coordinate axes are basically the x and the y axis at the points P and Q. Given that O is the origin, find the area of the triangle POQ. Okay, so first we need to figure out the perpendicular bisector of the line AB, and then it cuts the x-axis, you will get the point P. It cuts the y-axis, you will get the point Q. And then when you have a point P, Q and O, you need to just figure out its area for that triangle. Okay, so for perpendicular bisector of the line AB, we need the slope of AB and we need the midpoint of AB. Okay, so here first solve for the midpoint of AB. Midpoint of AB. So for midpoint, we need to add the x components and divide it by 2. So we know that 3 by 2 is 1.5. So minus 1.5 plus 2 divided by 2. This is the x component. And add the y components, minus 9 and 5. Minus 9, add 5 and divide it by 2. Okay. Let me use a calculator and simplify it. So here we have negative 1.5, add with 2, and you have to divide it by 2. This is 1 by 4 or 0.25. Okay, 1 by 4. And the other coordinate is minus 9 plus 5. Minus 9 plus 5 and divided by 2, which is negative 2. This is 0.25 and negative 2. See, these are the coordinates of the midpoint, right? Now we need to figure out the next thing is the slope or the gradient of AB. Slope of the point AB, that is equals to y2 minus y1 divides x2 minus x1, right? Okay, so y2 is 5 and y1 is 9. So 5 minus 9 divides 2 minus 1.5. So here we have 5 plus 9 divides 2 plus 1.5. Okay, so in 9, when you add 5, we have 14, and 1.5 add 2 is 3.5. And what is 14 divides 3.5? 14 divides 3.5, 4. This is the slope of AB. But we need to find the perpendicular bisector of the line AB. Okay, so if this is the line, we can say if this is a line AB, right, then this would be its perpendicular bisector. right? So perpendicular of AB. So as you can see, the line AB and the perpendicular, they are perpendicular to each other. So the slope of the lines which are perpendicular to each other are negative reciprocals of each other. So here we can say the slope of perpendicular bisector of AB is negative and the reciprocal of 4 is 1 by 4. So this would be the slope, right? Now let me solve for the equation of the line AB. So here we can say equation of, no, not line AB, perpendicular bisector of AB. Equation of perpendicular bisector of line AB. Equation of perpendicular bisector of line AB. Its equation is y minus y naught is equals to m into x minus x naught. You can use this form or y equals to mx plus c. Both are okay. M is your minus 1 by 4 and to get the c value, use the midpoint. Or if you're using this one, you can say this is your x naught, this is your y naught, and this value is your m. All right, so here we can say y minus y naught is negative 2, m value is minus 1 by 4 into x minus x naught is 0.25. Okay, let me simplify this. So this is y plus 2 equals to minus 1 by 4 into x minus 1 by 4. Or we can say y equals to minus 1 by 4 is multiplying with x, and minus times minus is plus, 1 times 1 is 1, 4 times 4 is 16, and subtract 2, shift the 2 on the other side. So what is 1 over 16 minus 2? 1 divides 16 and then subtract 2, that is minus 31 over 16. So y is equals to minus 1 over 4x and minus 31 over 16. Is it plus 31 over 16 or minus? Yeah, minus 31 over 16. All right. So this is my equation of perpendicular bisector of the line AB. So once we have the equation of perpendicular bisector of the line AB, it cuts the coordinate axes at the points P and Q. Okay. So this line we can say cuts x-axis, means y should be equals to 0, and it cuts y-axis, means x should be equals to 0. You will get the coordinates for the points P and Q. Okay, when it cuts the x-axis, your y equals to 0, so minus 1 by 4x minus 31 divided by 16, that is equals to 0. Let me solve for x. Minus 1 over 4x and shift this term on the other side, it becomes 31 over 16. So what is your x? X should be equals to 31 over 16, stays the same. Multiply, 4 is multiplying over minus 1. So when you simplify, 4 times 1 is 4, 4 times 4 is 16. So here we can say the x coordinate would be x is equals to negative 31 divided by 4. Okay, same we can say when it's x component is 0, y is equals to minus 1 over 4, x coordinate is 0, minus 31 over 16. So here y is equals to minus 31 divided by 16. So x is this term, sorry, and the y is this. Okay, now these are the points P and Q. So let me solve the decimal representation of this. Minus 31 over 16 minus 1.9375. Okay, and what about 31 over 4? 7.75, negative 7.75, and this one was 31 divide 16, 1.9375 minus 1.9375. Okay, so these are the coordinates of point P and Q. So you can fix any one as P and any one as Q, right? So we can say coordinates, here we can say coordinates of points P and Q are, okay, for coordinates of P, the x coordinate is minus 31 by 4 and the y equals to 0. For the coordinate of Q, the x coordinate is 0 and the y coordinate is minus 31 over 16. Okay, now we have the coordinates of P and Q go back. The perpendicular bisector of the line AB cuts the coordinate x's at the points P and Q, right? So we have done this. Given that O is the origin, find the area of the triangle P, O and Q. Okay, so we need to find the area for this triangle POQ. All right. Now let us visualize this situation. Now, what are the coordinates of A and B? Minus 1.5 and minus 9, 2 and 5. Okay, so if I can draw this line, okay, wait, let me do this over here. Okay, so what are A? Minus 1.5 and minus 9, and B is 3, 5. I think so. 2, 5. Sorry. This one is 2 and 5. Okay. Now first we need to plot the points A and B. So A is the point where x is minus 1.5 and the y value is minus 9. So this is a point A, and B is x is 2 and the y is 5. This is a point B. Okay. So let me join the A with the B. Okay. Now we need to find its perpendicular bisector. So let's say this is the perpendicular bisector of the line AB, right? Okay, hold on a second. So here the x coordinate is 0 over here and the y value is 0. So let's say this point is P, we can say, and y, this point is negative and the other one is 0. X is 0 and y is negative. Okay, so let's say this is the perpendicular bisector of the line PQ. The perpendicular bisector of the line AB. So let's say this is a point P and this would be your point Q, and this is my point P. Okay, now, and we have given that O is the origin. Okay, now we need to find the area. This O is the origin. Area of the triangle P, O and Q. Just consider this triangle. Let me highlight it. Yeah, this triangle. Yeah, this triangle you have to consider. Okay, so for this triangle P, O and Q, O is the origin, its coordinates are 0, 0. P has a coordinate minus 31 over 4 and 0, and Q has a coordinate 0 and minus 31 over 16. All right, now consider this triangle. Don't assume this line, okay, because we are not dealing with this line now. So as you guys can see, it is a right angle triangle. So area for the right angle triangle is half base times height. So you can take OP or OQ as a base and OP or OQ as a height. This is up to you, right? Okay, so what is the distance between this term? So there is just the x, the distance is just the y distance. So this distance is 31 over 16, this distance, and this, the distance from O to P is 31 over 4. Minus 31 by 4, and we have 0 from 0 to this point, it's 31 over 4, right? Okay, so now let me figure out the area for this triangle. So here we can say area of triangle OPQ, which is half base times height. This is half base, I'm going to fix OP, and the height I want to fix as OQ. So that is equals to half multiply the base is 31 by 4, multiply the height is 31 over 16. Okay, so let me simplify this. 1 into 31 into 31, so 31 times 31, that is 961, 961. 2 times 4 times 16, so here we have 2 into 4 into 16, that is 128. Okay, so this would be the area of the triangle, or you can convert it into decimal representation as well. So here we can say 961 divides 128, that is 7.507 or 7.51. 7.51 square units. That is the area of the triangle OPNQ. I hope this is clear now. Question number 2. The diagram shows the shaded region A, B, C, D. A, B, C, and D. The diagram show this is a shaded region. The line AC and BD, A to C, B to D, each has a length of 12 centimeter. A to C is 12, B to D is 12. The line AC and BC bisect each other at point O. So at this point O, they bisect each other. So it means this length is 6, this length is 6, this is 6, and this is 6, because the total is 12. So half of 12 is 6. Okay, the line AD and BC, AD, BC, they are parallel, and each have a length of 4 centimeter. This length is 4, this length is 4. Okay, the arcs AB and DC, AB, DC, these two are the part of a circle center at O. So if O is the center and O to A would be the radius, O to B is the radius, O to C is the radius, OD is the radius. So which is 6. Part A, find the obtuse angle. Obtuse angle is the angle which is greater than 90 degree and less than 180 degree, right? AOB, give your answer in terms of radians. Your answer should be in terms of radians, not in terms of degrees, right? Okay, now have to figure out this obtuse angle. This is the obtuse angle. Let's say this angle is theta. AOB we need to figure out. So for this, the whole circle is 360. Okay, so first thing I would like to solve for this angle or this angle, because all the three sides are for this triangle OBC OAD. So any two triangles you can pick, right? Because they are symmetrical, they have same lengths, right? And you can easily figure out one angle because all the three sides are given. When three sides are given, to figure out one angle, we use law of cosine, right? So here we can say apply law of cosine on triangle OBC. Okay, let me draw this triangle separately over here. Okay, so this is O, this is B, and this is C. B to C is 4. These are the radius. We need to solve for this angle. Okay, so to solve for angle O, its front side is 4, so we can say 4 square equals to the rest of the two sides are 6 square plus 6 square minus 2 into 6 into 6 and cos of the angle between them, which is O, right? So we have 4 square minus 6 square minus 6 square. What I did, I shift these two terms on the other side, and this term is multiplying, so over here it is going to divide. Minus 2 into 6 into 6, that is your cos of angle O. Okay, so now let me solve for that angle. So here we can say cos inverse, what is the angle O? So we can say the angle O is cos inverse of 4 times 4 is 16, 6 times 6 is 36, minus 36, and divided by negative 2 times 6 times 6 is 36. Okay, use a calculator and simplify. cos inverse 16 minus 36 minus 36 and divided by negative 2 times 36 and the bracket 38.94. So this angle is 38.94. uh, Sorry, this is in degrees or in radians? This is in degrees. We need to figure out in radian mode. Okay. Okay, so in order to convert it into this is degree and this is radians. Number 4, it's a radian mode. Now again doing cos inverse of bracket, we have 16 minus 36 minus 36, everything divide minus 2 times 36 and the bracket. Now we need to solve the angle in radians. 0.6796 or 0.6796. If I round it to 0.679 to 80, 0.680. Okay, this is in degree. Now for radian, 0.680 radians. Okay, because we need to figure out the angle in the radians, right? All right, now we have done with this angle. We have done with this angle and with this angle. Okay, the whole circle is in radians. It is equals to 2 pi, right? These two angles and these two angles, right? Okay, so here we can say complete circle is 2 pi, and this is a sum of the angles. So we can say we have some angle theta plus we have some angle theta plus we have 0.680 plus we have 0.680, and their sum should be equals to 2 pi. Okay, so here you can see this angle 0.680, 0.680. Let's say this is theta, this is also theta. Okay, so we have 2 times of theta equals to 2 pi minus the sum of these two. Let me do the sum of these two. So product times it by 2. It's 1.3593. 1.3593. Okay, so from 2 pi you have to subtract 2 pi, subtract answer. That is 4.9. 4.924. 4.924. Now in order to solve for that theta, so theta would be equals to 4.924. You have to divide it by 2. Okay, let me divide it by 2. 2.4619 or 2.462. So that is 2.462 radians. This is the angle in the radian mode. All right, so now for second part, use your answer to part A. This is answer of part A. To find part B, number 1, the parameter of the shaded region. So we need to figure out the parameter of this shaded region. So the parameter means the arc length AB, the arc length CD, and AD and BC, these are the 4, right? So basically we need to figure out the arc lengths, right? Okay. All right, so I dragged this picture separately over here. So we have to use the answer from part A. From part A, this angle is 2.462 radians. This angle is 2.462 radians. This side is 6, this side is 6. This is also 6, this is also 6. We have 4 and this is 4. Okay, so for the parameter of the shaded region is these two parallel sides BCAD, which is 4, and the arc length as well. Okay, so the formula for the arc length, the angles are in radians, so the formula is radius times theta. So the radius is 6 and the theta is 2.462 radians. Okay, so let me solve this. Okay, you have to just multiply it by 6, which is 14.77. that is equals to 14.77. Okay, so let me double check. Yeah, 14.77. This arc length is 14.77. This arc length is also 14.77. Now we can easily figure out the parameter. So the parameter of shaded region, that is equals to the arc length AB plus BC plus the arc length CD plus DA. Okay, so this is 14.77 plus 4 plus 14.77 and then plus 4. So there is 2 times we have 14.77. So here we can say this is times by 2. So this is 29.54, 29.54, and then add 4 plus 4, which is 8. Right. Now you have to add this thing by 8. Your parameter is 37.54 or 37.5. This is 37.5. This is the parameter. This is in centimeters. Yeah, in centimeter. So 37.5 centimeter. This would be the parameter of the shaded region. Now for the second part of B, the area of the shaded region. Okay, so we have done the parameter of the shaded region and we have to use the answers to part A to do these two parts. Okay, the area of the shaded region. So I pasted the picture over here. So the area of this shaded region is basically the area of the sector of a circle AOB, area of the triangle BOC, area of a sector DOC, and area of a triangle AOD. So these two are the triangles and these two are the sectors of the circle. Okay, so let me substitute the values. This is 6, 6, 6, and 6. This length is 4 and 4. So what is this angle? We have done with these angles as well. Okay, so this is 6.4, 2.462. This is also 2.462, and we have done with the angle, this angle as well, BOC, the angle O for while applying the law of cosine, 0.680. So 0.68. This is also 0.68. Okay, so now we have everything. We need to solve for the area of the shaded region. Area of two sectors, area of two triangles. If you solve for area of this sector is also same because they are symmetrical. Area of this triangle and this triangle is same because they are symmetrical, right? So let me solve for the area of sector AOB, or we can say DOC, both are equal. So area of a sector, since the angles are in radian, is half radius square theta. This is the formula. So we have half. What is the radius? Radius is 6, take it square. And what is theta? 2.462. That is your theta. Okay, so let me simplify. 2.462 is multiplying by 6 times 6 is 36, and you have to divide it by 2, and that is equals to 44.32. This is 44.32. This is the area of this sector, right? So for two sector, you have to product by 2, right? Now area of a triangle, area of triangle BOC, or the triangle AOD, which is half AB sine C. This formula we have to use for the area of the triangles, right? Because they are not right angle triangles. For right angle triangle, we have to use the other formula, half base times height, right? Okay, so we have half the two sides, 6, 6, and sine of angle between them. 6 times 6 times sine of the angle should be in radian, 0.68. This is the angle in radians, keep it in mind. Okay, my calculator is in the radian mode. Okay, so what is sine of 0.680? And you have to times it by 6, times by 6, and you divide it by 2. 11.32, that is the radius area, 11.32 for this triangle and for this triangle as well. Okay, now to solve for the area of the shaded region, area of shaded, sorry, region, that is area of two sectors, area of two sectors plus area of two triangles. Okay, so the sectors area is 2 times 44.32 plus the triangle areas are 2 times 11.32. Why times by 2? Because there are two triangles and two sectors, right? So you will get the total area. Okay, 2 times 44.32 plus 2 times 11.32. This area is 1128 or 111.3. 111.3 centimeter square. That is the shaded area for this shape. Question number 3. Find the exact value of the term independent of x in the expansion of this. You guys can see it's a product of two expansions. So here the power is 10 and here the power is 2. So you can use a minus b whole square formula over here. So it is better to find that the term independent of x, it means constant term. We need to solve for the constant term, or we can say x to the power 0. This is also the constant term. So I would like to take this. So we can say let 2 plus 3 over x square, its whole power is 10. So I have to use this binomial expansion first, right? Okay, let me open this binomial expansion. 2 to the power 10 plus 10c1, 2 to the power 9. We have 3 over x square to the power 1 plus 10c2, 2 to the power 8. We have 3 over x square to the power 2. So this is a constant term. This is 1 over x square term. This is 1 over x4 term. And then 1 over x6, 1 over x8, 6, x8, yeah, those terms. And if I open the expansion, 1 minus 4x square whole square, this is 1 square, minus 2 into 1 into 4x square plus 4x square whole square. I opened the formula over here. This is a minus b whole square. So we have a square minus 2ab plus b square. So this formula I have applied over here, right? Okay, so when I simplify, this is 1 minus 4x square whole square. This changes to 1 square is 1 minus 2 times 4 is 8 x square and plus 4 times 4 is 16 x square times square is x to the power 4. Okay, so now when you simplify this as well, which is 2 plus 3 over x square to the power 10. Let me simplify this. 2 to the power 10. Let me do this. 2 to the power of 10 is 1024. 1024. 10c1, 2 to the power 9. 10c1, this is 10. Multiply 2 to the power 9, which is 5120. Multiply by 3, which is 15360. 15360. So 10c1 multiply by 2 to the power 9 multiply by 3, everything divide by x square, right? Now the second thing we can do, 10c2. 10c2 is 45. Multiply 2 to the power of 8 and multiply 3 to the power of 2. 103,680. 103,680. 103,680. Everything divide x to the power 4 and plus so on. Here you will get 1 over x6, 1 over x8, 1 over x, x 10 terms. Yeah. So when you do the product of these two, do the product of these two, because we have in the product, these two things are in the product. So let me simplify. 2 plus 3 over x square to the power 10, its product with 1 minus 4x square whole square. So here we open 1024 plus 15,360 over x square plus 103,680 over x to the power 4 plus we have so on the other values, its product with 1 minus 8x square plus 16x to the power 4. Okay, so why I stopped at x to the power 1 over x4? Because most of the student will ask why I didn't proceed further, 1 over x6 term, 1 over x8 term. Because as you can see, when I opened the square of this term, I got the highest power x to the power 4. So this x to the power 4 and 1 over x to the power 4 is cancelled out. You will get the constant term, right? Okay, now we have to only solve for the constant term. Solve for constant terms only. Okay, so let me solve for the constant terms only. Okay, now this term is going to multiply with 1. You have 1024 multiply by 1. This term multiplying with x square term. This term multiplying with this x to the power 4 term. We don't need it. Plus this term multiplying with 1 is 1 over x square term. This term is going to multiply with x square term. So you guys can see this and this. It gives you the constant term. 15,360 over x square. When this term is multiplying with minus 8x square, you will get the constant term. Plus again this 1 over, this would be x square term, x4 over x square term, we don't need it. This multiplying with 1, 1 over x4 term, this is 1 over x square term, and this would be the constant term. 103,680 over x4, its product with 16x4. Okay, now we can cancel x4 with x4, x square with x square. Simplify this further. So here we have 1024, this term multiplying with negative 8. 15,360, yeah, multiply negative 8, that is minus 122,880, minus 122,880 and 0, plus this thing multiplying by 16. 16 is multiplying with 103,680. 165,880, 165,880 and 0. Okay, now simplify this. This term is going to add with 1024 and then subtract it with 122,880, which is 1,537,024. Yeah, 1,537,024. So this is the answer, which is a term independent of x. So you need to solve the exact value of the term independent of x in that expansion. So this would be the exact value. Now for question number 4, variables x and y are such that when e power y is plotted against x cube, a straight line graph is obtained. Okay, so what they are trying to say that now x-axis becomes x cube and the y-axis is e power y. Okay, so when e power y is plotted against x cube, they said a straight line graph is obtained. This is a straight line graph is obtained. Okay, so we know that the equation of a straight line is y equals to mx plus c. When x is plotted against x, we have this equation, right? And now x cube is plotted against e power y, so now your equation becomes e power y equals to m, x is x cube and plus c. This would be your straight line equation. Okay, this line passes through the points. These are the 2 points where it passes through. Let's say this is the first point, this is the second point. Now your first, this x chord point is basically x cube, and the y point is your e power y. This is your x cube and this is my e power y. Now part A, find y in terms of x. Okay, so first let me write down the equation. E power y is equals to m x plus c. Now the first step is to plug the point. The first point is 1 and 13.5. If I plug this point, uh, e power y is 13.5 equals to m, sorry, this is x cube. M, x cube is your 1 because it is plotted against x cube, and then plus c, right? So this is my first equation. Now take the second point. The x cube value is 7.5 and e power y is 0.5. Okay, this e power y 0.5 equals to m, x cube is 7.5 and plus c. This is my second equation. Okay, so we need to solve these two equations to get the value of m and c, and then plug into your we can say equation static, and you will m and c, and then you can solve y in terms of x. Okay, so now let me solve for m and c. How can we do this? If I multiply the first equation by 7.5 or negative 7.5, if you do multiply by 7.5 then subtract, or multiply by negative 7.5 and then add them up, this is up to you, right? So here we can say multiplying equation 1 by 7.5. Why I am multiplying with 7.5? No need to multiply. You can just cancel, subtract the two equations and cancel the c. Yeah, so no need to multiply because this would be easy. So if you multiply your first equation by, if you are canceling the m, then multiply your first equation by 7.5, right? And if you multiply your m with 7.5 and subtract, you can cancel the m. Or you, if you can just subtract the two equations, you can cancel the c. So you can say subtract equation 1 and equation 2. Okay, so when we are subtracting the two equations, we have m plus c, this is 13.5, and 7.5m plus c is 0.5. So whenever we subtract the two equations, basically we have to change their signs. Okay, so now positive c and negative c, this is cancelled out. So what is 1 minus 1.7? So 1 minus 1.7 is negative 1.6, negative 6.5 m, and that is, let me do the calculator, 13.5 subtract 0.5, 13. Okay, solve for m. So what is m? M equals to, from 13 you have to divide by minus 6.5. Okay, 13 divides 6.5, it's 2, so m value is negative 2. So from here m equals to negative 2. We got m. Now we have to solve for c. We have the m value. Now to solve for c, you can plug this m value into the first equation and solve for c. So you can say put m equals to -2 in equation 1. Equation 1 is m plus c equals to 13.5. C would be equals to 13.5 minus m. C equals to 13.5 minus m is minus 2. So C would be equals to 13.5. Negative times negative is positive 2. And 13 plus 2 is 15. So C is 15.5. We got the C as well. We have C and we have M. Just plug these two values into your equation static. The M over here and the C over here. Okay. Let me separate this. Okay. Now put m equals to -2 and c equals to 15.5 in equation static. Okay, equation static is e power y equals to mx cube plus c. So e power y equals to m is -2x cube and c is 15.5. Now we can easily solve y in terms of x. Okay, so how can we do this? Y in terms of x. So basically, we have to take a natural log on both sides, right? So natural log e to the power y equals to natural log minus 2x cube plus 15.5. Okay, now for natural log, the power comes before the log. Y natural log e, this is natural log of 15.5 minus 2x cube, and we know that natural log of e is always equals to 1. So this thing is 1, so y would be equals to natural log of 15.5 minus 2x cube. Now you can see this is y in terms of x. So we have solved y in terms of x. Sorry. Okay, so we just need to find y in terms of x. Now for part B, find the values of x for which your equation is valid, for which this equation is valid, for what values of x this equation is valid. So we can say the equation y equals to natural log of 15.5 minus 2x cube is valid when the argument of log is greater than 0. When 15.5 minus 2x cube, this should be greater than 0. When this is the argument of log, when this thing is positive, because when this thing is 0, ln of 0 is infinity and ln of negative number does not exist, so it should be positive, right? So if it is positive, we need to solve for those values of x. Let me simplify. So here we can say minus 2x cube stays over here, is greater than minus 15.5. Now we can, when we cancel the negative sign, so we divide by minus 1, divide by minus 1 on both sides of inequality, we have to reverse the inequality. So 2x cube is less than 15.5. So x cube is less than 15.5 divided by 2. What is 15.5 by 2? We have 15.5 divided by 2 is 7.75. So x cube should be less than 7.75. And when we have to solve for x, right? So taking a cube root on both sides, so cube root over here and applying the cube root here. So this cube and the cube root is cancelled out, and here the x should be less than cube root of 7.75. So these are the values of x when your equation is valid. All right. Question number 5. A 6-character password is to be formed from the following characters: letters, some numbers, and some symbols. Each character can be used at most once. Each character can be used at most once in any 6-character password. Part A, find the number of 6-character passwords that can be formed if there is no further restrictions. Okay. So how many letters? 1, 2, 3, 4, 5. Numbers 1, 2, 3, 4, and symbols 1, 2, 3. So the total are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we can say the total is total characters are 12. Okay, so there is no further restrictions, just you have to use each of the character at most once, right? So for the 6-character password we can say 1, 2, 3, 4, 5, 6. All right. Okay, so for the 6-character password, it starts, let's say the first digit have 12 options from all these letters, numbers, symbols. The second has 11 options are left. For the third character, how many options? 10 options are left. For the fourth character, 9 options are left. For fifth character, 8 options are left. And the sixth character, only 7 options are left. Right? So here you can, this way you can find make a 6-character password. Okay. So this is how you can make a 6-character password. All right. So let me use a calculator and simplify. What is 12 into 11 into 10 into 9 into 8 into 7? 665,280. So 665,280. So we can make 665,220 6-character passwords if we can use at most once of any of these characters, right? All right, now for part B, find the number of 6-character password that can be formed if the password starts and ends with a symbol. Okay, so these are the symbols. It starts with a symbol or end with a symbol. Starts and end, not or, sorry. Okay, so how many letters? We have 5 letters, we have 4 numbers and 3 symbols. 5 letters, 4 numbers, and 3 symbols. The total characters are 12. Okay, so if I make a 6-character password, 1, 2, 3, 4, 5, and 6. Okay, if it starts with a symbol, let's say it start with a symbol static. So how many option for that? The first digit, the first character. We have 3 options for the first character because the 3 symbols we have. Now one symbol is already used. How many options are left for the last one? 2 options are left. Let's say this is used. Now when you use these two, how many are in the middle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 options for the second digit, and then we have 9 options, and then 8 options, and then 7 options. This is how you can solve this. Okay, let me use a calculator. So here we have 3 into 10 into 9 into 8 into 7 into 2. Sorry, 2. So 30,240 option. 30,240. All right. All right, now for part C, find the number of 6-character password that can be formed if the password starts with either a symbol and then a number, or a number and then a symbol, and ends with 2 letters. Okay, so the start option is given and the end option is given. Okay, so there are 2 cases. So the start, 1, 2, 3, 4, 5, 6, right? This either or, there are 2 options, right? Either this or this. 1, 2, 3, 4, 5, 6. Okay, now It start, let's say, ends with two letters. So here we have letter, here we have letter, and here we have letter, and here we have letter. Start with the symbol and then we have a number, or a number and then we have a symbol. Okay, now go up and find out how many symbols, numbers, and letters we have. Okay, so symbols are 3, numbers are 4, letters are 5. Okay, symbols are 3. There are 3 symbols. Numbers we have 4. The letters are 5. Symbols are 3. Numbers are 4. The letters are 5. Okay. So from 3 symbols, the first option, take 1 symbol. Let's say the symbol static is taken. From 4 number, take 1 number. Let's say 3 is taken. Okay, so from 5 letters, take 1 letter. Let's say B is taken. When B is taken over here, how many letters are left? 4 letters are left. So F is also taken. So B, F, static, and 3 is taken. Okay, when B, F, static, and 3, these are taken, how many left? 1, 2, 3, 4, 5, 6, 7, 8. So 8 options are left for the 8 options here. And here we have, wait. Okay, so for this number, 8 options are left and then 7 options are left. Do the product of all 3. You can solve for the first case. Okay. All right, so here we have 3 into 4 into 8, 3, 4, 8, 7, 5, and 4. Sorry, into 7 into 5 into 4. 13,440. 13440. Okay, now numbers are 4, take 1 number. 3 symbols are 3, take 1 symbol. Static letters are 5, take 1 letter, B. And now 4 letters are left, F. We are doing the same thing, right? And now how many options are left? 3 static, B, and F is taken. 3 static, B, F is taken. Now we have just 8 options are left. Okay, so the middle 2 numbers, third number, 8 options are left, and the fourth character, 7 options are left. So everything is same: 4, 5, 7, 8, 4, or 3. So it's again 13,440. Okay, so for the total we do the add. So number of passwords are going to be 13,440 plus 13,440. Okay, and let me times it by 2. 26,880. So 26,880 passwords we can do by using the third case, part C. Yes. Question number 6. In this question, lengths are in centimeters and time t is in seconds. Okay, a particle P is moving in a straight line with the speed 26 and in the direction of the vector 5 and -12. Part A, find the velocity vector of particle P. Okay, since that particle is moving in a straight line, the speed of the particle is given and the direction vector is given. We need to solve for the velocity vector. So use the formula that the velocity vector is always equals to speed multiply by the direction vector divides magnitude of the direction vector. That is the formula to get the velocity vector. Okay, so here the velocity vector of the particle P, so the velocity vector would be the speed is 26. It is going to multiply by the direction vector. We can write the direction vector as 5i unit vector minus 12j unit vector divides the magnitude of this vector. Magnitude means the square root of the I component square plus the j component square. Okay, let me simplify. Square root 5 square plus 12 square, that is 13, because negative square is also positive, so it's just 13. So this would be equals to 26 multiply 5 I unit vector minus 12 j unit vector divided by 13. Okay, and when we simplify this, 13 times 2 is 26. Okay, so now you will get the velocity vector. Velocity vector becomes 2 times of 5 I unit vector minus 12 j unit vector, right? Or this should be 2 times 5 is 10 I unit vector minus 2 times 12 is 24 j unit vector. This, or we can also write this as a column vector, which is 10 minus 24. You can do both representation this way or in a column way. So this would be the velocity vector of the particle P, which is 10 I unit vector minus 24 j unit vector. Now for the second part, when time equals to 0, P passes through the point A, which has a position vector 3, 6. Part B, write down the position vector of P at time t. Okay, so for now we use a formula for the position vector. Okay, so the position vector of P, that is equals to the position vector of A, position vector position vector of A, because point P passes through A. When time is t, when the t value is 0, P, the particle P passes through the point A. So the position vector of a particle P would be position vector of A plus t times the velocity vector of particle P. This formula we have to use. Okay, so the velocity vector is 10 and negative 24. Okay, so this is 3, 6 is the position vector of a particle A plus t times the velocity vector of the particle P, which is 10 and negative 24. You have to simplify and you will get this as a position vector of the particle P. Now the position vector of the particle P, this becomes 3 plus 10t and 6 minus 24t. This would be the position vector. Now for part C, at the same time that P passes through a particle Q passes through B. The position vector of Q at time t is given by this. So the position vector of P is this, the position vector of Q is this. P passes through A, Q passes through point B. The distance between P and Q at time t is d. So the distance we have given, that is d. Part C, show that d square is mt square plus nt plus r, where m, n and r are integers to be found. Okay, so we need to figure out the distance between the particle P and the particle Q at time t, that is d, and then take its square. Okay, so d is basically the distance between the position vector of A, position vector of particle P minus the position vector of the particle Q. Okay, so this is d. Position vector of P is 3 plus 10t and 6 minus 24t. Subtract for Q, we have 8t minus 5 and 2 minus 25t. All right. Let me solve for d, which is 3 plus 10t minus 8t and plus 5, and 6 minus 24t minus 2 plus 25t. Okay, 3 plus 5 is 8, and 10 take away 2 would be 2. 8 plus 2t, and 6 take away 2 is 4, and 5 take away 24 is plus t. This is d. Okay, this is a difference between the two, right? Okay, now we need to solve for the distance. What is the distance formula? Square root of x2 minus x1 whole square plus y2 minus y1 whole square and the square root. That is your d. So here we have done x2 minus x1, y2 minus y1. So just take this is your value of this. The top one is x2 minus x1 and this bottom one is your y2 minus y1. So take their square, right? So now this is d. So what is d square? So when you do the squaring on both sides, this is the d value, take it square, the square root is cancelled out. Okay, so this implies we have 8 plus 2t its whole square plus 4 plus t its whole square, because we have to make the equation in this form, d square equals to something. So that is why I took the square. So d square, open the square, a plus b whole square. 8 times 8 is 64. 2 times 2 is 4t plus 8 into 2 into 2. 2 times 2, 4. 4 times 8 is 32. Yes, 32t square here. 4 times 4, 16. T times t square. 2 times 4 is 8t. Okay, so now d square would be, the square terms are 4t plus t, so 5t square. The t terms are 3 and 8, 8, 9, 10, 11. Sorry, it's 32. Okay, it's 32t, because when you do 2ab, 2 times 2, 4, and 4 times 8 is 32. 32 plus 8 is 40t, and the constant is 64 and 16. So when you do 64 and then add with 16, so 6 and 4 is 10, 6, 7, 8, so it's 80 plus 80. So this is your d square equals to mt square plus nt plus r. So mt square plus nt plus r, where m is 5, n is 40, r is 8, 80, and they are integers. So this is the final answer. Now for part D, hence show that P and Q do not collide. It's a 1 mark question, so you have to give a correct argument that the particle P and Q do not collide. So we can say let P and Q collide. So when P and Q collide, this implies their distance should be equals to 0. When the two particles collide, it means their distance are 0, right? Okay, so when d value is 0 over here, we can say 5t square plus 40t plus 80, that should be equals to 0. Okay, everything is divisible by 5, divided by 5, divide by 5, and divide by 5, right? Now this is t square, 5 times 8 is 40 and 5 times 16 is 80, that is equals to 0. Now when you do, this is t square plus 2 into t into 4 makes 8. 2 times 4, 8, and t, and 16 is a square of 4. So here we have a square plus 2ab plus b square. So this is t plus 4 whole square formula. This is equals to 0. This implies t plus 4 would be equals to 0, and we got t value equals to -4, which is not possible. This value is not possible because time is always greater than equals to 0. If it is 0, time is 0, or time should be positive. So with the help of this whole mathematical simplification, we come to know that the particle P and Q do not collide, right? So here we can say hence P and Q do not collide. because when they collide their distance is 0, and when their distance is 0, the time value is negative, which is not possible. Question number 7, part A, given that y equals to x cos 2x, find dy by dx. So to solve for dy over dx, we have to use the product rule over here, because it's a product of two functions. The first function is as it is, derivative of the second function, d over dx of cos 2x, plus the second function is as it is, cos 2x, the derivative of the first function, d by dx of x. So now dy over dx becomes x, the derivative of cos is minus sine 2x, and the derivative of 2x is 2, plus cos 2x is as it is, dx over dx, this is just 1. So the simplified form of dy over dx, that is equals to negative 2x sine of 2x plus cos of 2x. This is the derivative of this function. Now for part B, hence find the integration of x sine 2x dx. Okay, so what we have done that d by dx of the function y. So what was the function y? X cos 2x. X cos of 2x, that is equals to minus 2x sine 2x plus cos 2x. Okay, so we hence means use answer from your part A. Now we need to figure out its integration, right? So let me apply the integration on both sides. Integration, integration, and integration on every term. Okay, so now integration d by dx of cos 2x, wait, of x cos 2x with respect to dx, that is equals to negative 2 is outside, integration of x sine 2x dx plus integration of cos 2x dx. Okay, now you can see this dx is cancelled with the dx, derivative is cancelled out with integral, you are left with cos x cos 2x, that is minus 2. This integration we need to solve, so keep it as it is, sine 2x dx plus the integration of cos is sine 2x multiply 1 over the derivative of 2x is 2 plus the constant of integration. Okay, now we have to solve this, shift this term on the other side. So 2 is positive, integration x sine 2x dx, that is equals to, shift this term on the other side, minus x cos 2x plus sine 2x divided by 2 plus the constant of integration, right? Now in order to solve for this integral, divide everything by 2. So integration of x sine 2x dx becomes minus 1 over 2 x cos 2x plus 1 over 4 sine 2x plus c over 2. So we can replace c over 2 as c prime. Okay, so I'm doing c prime over here, where c prime is constant divided by 2. So any constant divided by 2 is again a constant, right? So this is the integration of x sine 2x. Question number 8. An arithmetic progression has a first term t and common difference 1.5. So it is an arithmetic progression. We have given the first term and the common difference 1.5. Okay, so for arithmetic progression, we have the nth term an is equals to a 1 plus n minus 1 into d. Okay, now what we have given that the first term a1 is t and the common difference d value is 1.5. So here the nth term is t plus n minus 1 into 1.5. Okay. The fourth, eighth, and 20th term of this arithmetic progression forms the first, second, and third term of a geometric progression. Okay. Okay, now let me solve for the fourth term, A4, for the eighth term, A8, and for the 20th term, A20. Okay, so this is t plus 4 minus 1, which is 3 times 1.5, t plus 8 minus 1, 7 times 1.5, and t plus 20 minus 1, 19 times 1.5. Okay, so here we have t plus 3 times 1.5 is 4.5. Yes, it's t plus 4.5. The second is t plus 7 times 1.5 is 7 into 1.5 is equals to 10.5, and t plus 19 times 1.5 becomes 19 times 1.5, 28.5. This is 28.5. So these terms, they said that these are the first, second, and third terms of geometric progression. Okay, so we have to solve for t in part A. So these are the first, second, and the third term of the geometric progression. So it means we have a geometric progression now, and the first term of the geometric progression is t plus 4.5. The second term is t plus 10.5, and the third term is t plus 28.5. Okay, for geometric progression we have a common ratio, right? So geometric progression we have a common ratio. Okay, so the common ratio, sorry, in common ratio we can say the second term divides the first term should be equals to the third term divides the second term. Second over first should be equals to third over second. So from here we can say that t plus 10.5 divides t plus 4.5, that should be equals to t plus 28.5 divides t plus 10.5. Second over first, third over second, they are equal. Now we can just use this and solve for t. Cross multiply here. So t plus 1 10.5 is multiplying with t plus 10.5, sorry, 10.5, and here t plus 28.5 multiplying by t plus 4.5. All right, so let me solve this. T times t would be t square plus t 10.5 t, again 10.5 t, and what is 10.5 times with 10.5? 10.5 times, sorry, 10.5, 110.25, 110.25. Okay, now this is t times t would be t square, t times 4.5, which is 4.5t, and now 28.5t, and what is 28.5 times by 4.5? 28.5 times 4.5, 128.25, 128.25. Okay, now let me simplify this. T square plus 10.5t plus 10.5t, 10.5 plus 10.5, 21 t plus 110.25. This is equals to t square plus 28.5 add with 4.5. 28.5 add 4.5. 33 t plus 128.25. Now you can see t square in t square both are cancelled out. Now combine the t terms. We have 21 with t and minus 33 with t. And now combine the constant terms 128.25 and shift this over here minus 110.25. Okay, let me simplify this. Okay, we have 21 take away 33. This is negative 12t. And the other one is 128.25 take away 110.0.25. 18. So t is equals to 18 divides negative 12. And when we simplify this, we have 2 times 6 is 12, 2 times 9 is 18, 3 times 3 is 9, 3 times 2 is 6. So from here the t value is negative 3 by 2, or we can say negative 1.5. So we just need to solve what is the t value. So we have done with the value of t. Now for part B, find the common ratio R of the geometric progression. So what was the common ratio R? This was the geometric progression. So its common ratio is this term divides this term. Okay. So the common ratio R is when you divide 10 plus t plus 10.5 over t plus 4.5. Okay. T plus 10.5 divides t plus 4.5. Now what is the t value? Now the t value is minus 1.5. Just substitute the t. Okay. So r is equals to minus 1.5 plus 10.5 divides minus 1.5 plus 4.5. Okay. Minus 1.5 and 4. From 10.5, if you take away 1.5, you have 9. And from 4.5, take away 1.5 is 3. 3 times 1 is 3. 3 times 3 is 9. That is equals to 3. So this implies a common ratio R is 3. We got the value for the common ratio. Question number 9, it is given that f of x is natural log 2x plus 5 for x should be greater than a, where a is a constant. So the domain is x should be greater than some number. Part A, write down the least possible value of a. So how do we write the domain for the logarithmic function? So the log function exists when the argument of log or the function inside the log should be greater than 0. So it means 2x plus 5 should be greater than 0, and 2x should be greater than negative 5, and x should be greater than negative 5 by 2. So x should be greater than a. So here x should be greater than a, x should be greater than negative 5 by 2. So what is the least possible value of a? So that value is minus 5 by 2. Part B, using your value of a, which is minus 5 by 2, write out the range of f. Okay, so for logarithmic function, if we can graph out the logarithmic function, so we can say this is how the graph of the logarithmic function. This is the log function, right? Just a rough sketch. So with the log function, what is the range? The y values are 0, positive, negative, all the y values are included over here, right? So the x values should be greater than minus 5 by 2. So minus 5 by 2 is 2.25. Okay, so if I can raise this everything and graph this out, this is how the shape of logarithmic function, right? So if I can graph this logarithmic function, and this is basically negative 2.5, so x values are more than minus 2.5, so less than minus 2.5. This is how the graph look like. This is y equals to f of x. this the values of x are negative 2.5. Negative 2.5 means more than minus 2.5. So what happened to these y values? Y values are all, it use 0, positive, negative. So we can say the range of f of x is all real numbers. Okay. Okay, it is also given that g of x we have is a quadratic function for x belongs to real number. Part C, use your value of a, solve the equation g f of x is 4, f g of x is 4. Give your answers in exact form. It must be more than one answer, right? Okay, g f of f g of x would be equals to 4. Okay, so f and g of x is x square plus 1, that is equals to 4. And what is f of x square plus 1? So this is ln 2x is replaced with x square plus 1 and plus 5. So this is ln 2 plus 5, that is equals to 4. Now we have to solve for x by using that value of a. Okay, by using that value of a, it means the composition is possible now, right? Okay, so if we can simplify this, we can convert the logarithmic to exponential form. So we can say 2 times x square, 2 times 1 plus 5, that is equals to, natural log is basically exponential, so e to the power 4, right? So 2x square plus 7, that is e to the power 4, right? Further simplification, we can say 2x square, that is equals to e to the power 4 subtract 7, and x square is e to the power 4 minus 7 divided by 2, or we can say that x should be equals to plus minus square root of e to the power 4 minus 7 divided by 2. So these are the two exact solutions, not in the we need to solve for the exact form, not the decimal form. So these are the two exact solutions of x, because when we do the square root on both sides, it's plus minus. Question number 10. The diagram shows parts of the graph of y equals to this and y equals to this, these two functions. The part of the graph of these two functions. Find the area of the shaded region. We have to solve for the area of the shaded region. So this is a shaded region. We need to find the area between the two curves basically. Okay, so whenever we have area between the two curves, what we have to do? We have to find the area of the upper curve, subtract the area of the lower curve, and from the limits, the x values. Okay, give your answer in the form of a plus b natural log of 3, where a and b are exact constants. All right. So first thing, we need to find their point of intersection. What is the point of intersection? What is the x coordinate of the point of intersection where these two functions meet? Okay, so first thing, x coordinate of point of intersection of two curves. Okay, so these are the two curves. We can put both of them equal. So we can say 4 minus 3 e to the power 2x. This should be equals to 2 plus 5 e power x. Okay, so minus 3 e power 2x and plus 5 e power x, that is equals to 2 take away 4. All right. Now minus 3 e power 2x plus 5 e power x is equals to negative 2, or minus 3 e power 2x plus 5 e power x plus 2, that is equals to 0. Now you can see this look like a quadratic equation in a variable e power x. You can factorize it or apply the quadratic formula. Yeah. Okay, let's see the factorization is possible or not. So, or if it is, you can say minus 3 times 2 is minus 6. and we can say 6 times minus 1 is minus 6, and 6 take away 1 is 5. So we can write them it down. Minus 3 e to the power 2x plus 6 e to the power x minus e to the power x plus 2, that is equals to 0. Now let me take 3 common and e to the power x common. Minus e to the power x is left and 3 times 2 is 6. Take 1 common, so minus e to the power x plus 2, that is equals to 0. So the factors are minus e power x plus 2 and the other factor is 3 e to the power x plus 1, that is equals to 0. Now put both factors separately equals to 0. From here we can say minus e power x plus 2 should be equals to 0, or 3 e power x plus 1 equals to 0. Minus e power x equals to minus 2. Negative is cancelled with negative. E power x should be equals to 2. And 3 e power x is equals to negative 1. And e power x should be equals to minus 1 over 3. Okay. Now to solve the exponential, taking natural log on both sides. Natural log e power x equals to natural log of 2. Natural log e power x equals to natural log of negative 1 over 3. Hold on a second, I did the mistake. It's negative, and when you shift this term on the other side, it is also negative. This term is negative, this term is negative, this is also negative. Oh my bad, I messed up everything. Okay, so it's minus 5, so it means this is negative and this should be positive. It's negative and positive. Now you have to take a negative sign common. Yeah, take a negative sign common. When I took the negative sign common, it means I have positive. Minus 3 is common, right? And these two are already positive. 1 is common. So this is e power x plus 2, and here minus 3 to the power x plus 1. It's negative 3. So further simplification, where is the razor? Wait, hold on a second. Let me solve the first one. Okay, this term equals to 0 equals to this. Taking natural log e to the power x, and here we have natural log of negative 2. So natural log of negative number does not exist. So when it does not exist, so we have no solution from here, right? No solution. All right, now let me try the second one, which is negative 3 e power x plus 1 equals to 0. This is negative, these two negative signs are cancelled out, and you have to raise this. Okay, when these two are cancelled out, e power x is 1 over 3. Now here e power ln of e is just 1, so x should be equals to natural log of 1 by 3. So natural log of 1 by 3, their point of intersection, the x coordinate of point of intersection is natural log 1 by 3. This is the x coordinate of point of intersection, and other x coordinate is the point where x is equals to 0. So we have to integrate. To get the area between the two curves, we need to integrate the upper curve from 1 over the upper curve from 0 to natural log of 1 over 3. It should be negative. Yeah, it can be negative when you do minus natural log of 3, because it's my natural log of 1 minus natural log of 3. Let me show you how I did this, because most of the student will get confused. So when you open, log of a by b is log a minus log b. Natural log of 1 is 0. 0 minus natural log of 3. So this can also be write down as minus natural log of 3. So we have to, this should be negative because here the x values are negative, right? So integrate the upper curve from 0 to minus natural log of 3. Subtract integration of the lower curve from 0 to minus natural log of 3. This would be the area of the shaded region. This would be your upper curve and this is the lower curve. Okay. So here we can say the shaded area is integration from minus natural log of 3 till 0. Upper limit should be bigger. Yes. Okay, so the upper in curve is 2 plus 5 natural log of e. 2 plus 5 natural log of x, e to the power x, minus the lower one is 4 minus 3 e power 2x. 4 minus 3 e power 2x dx. 2 plus 5 and 4 minus 3, double check. 2 plus 5, 4 minus 3, yes. Okay, let's do the integration. Integration minus natural log of 3 till 0. So 2 plus 5 e to the power x minus 4 plus 3 e to the power 2x. I open the minus sign. This is minus and this becomes plus with respect to dx. Okay. Now further simplification, we have integration minus natural log of 3 till 0. So from 2 take away, okay, first 3 e power 2x, and then we have 5 e power x, and then we have negative 2 with respect to dx. Let me solve this. So 3 e power 2x integration is e power 2x divided by 2x derivative is 2 plus 5 e power x integration is e power x divided by x derivative is 1 minus 2x. And it's a definite integral. Apply the limit minus natural log of 3 till 0. Okay, now we have to apply limits to get the exact area. And it should be in the form, not the exact one. It should be in this form: a plus b natural log of 3, where a and b are exact constants. Okay, let's see what happened. So here the area, applying the upper limit, 3 by 2 e to the power 0 plus 5 e to the power 0 minus 2 into 0. This is my upper limit. Subtract the lower limit, 3 by 2 e to the power 2 minus ln 3 plus 5 e to the power minus ln 3 and minus 2 into minus natural log of 3. Okay, so here e to the power 0 is 1, 3 by 2 plus 5 and minus 0, 2 times 0 is 0, minus this is 3 by 2. Okay, e to the power natural log 3 to the power minus 2. So power comes, this coefficient comes into the power of the log. Okay, so 5 e to the power e to the power natural log of 3 to the power negative 1, so it's minus 1. So this is plus 2 natural log of 3. Okay, now simplify this. 2 times 5 is 10. In 10 you add 3 is 13. 13 divided by 2, and minus we have 3 over 2. E and natural log is just 1, so we have 3 to the power minus 2. We have 5. E natural log is 1. 3 to the power negative 1 plus 2 natural log of 3. Okay, so 13 divided by 2 minus, we have 3 by 2 multiply 1 over 3 square minus 5 multiply 1 over 3 minus 2 natural log of 3. So I open this and put the negative sign. It's, yeah, inside the bracket. Okay, this is 13 over 2 minus this 3 and 3 is cancel out, so it is 1 over 6 minus 5 over 3 minus 2 natural log of 3. Okay, now let me simplify everything, but it's in the bracket. So 13 divided by 2 and then subtract 1 over 6 and then subtract 5 over 3, 14 over 3. So this is 14 divided by 3 minus 2 natural log of 3. Now this is in the form of a plus 2 natural log of b, where a and b are exact constants. A plus b ln 3, a plus b ln 3, a plus b, sorry, the answer should be in the form of a plus b ln 3. This implies the a value is 14 over 3, which is the exact constant, and the b value is negative 2, which is the exact constant. Question number 11, part A. Solve the equation tangent square 2x minus 4 tangent x equals to 0 for x is between 0 degree to 180 degree. Okay. So let me solve this equation. From here we can take tangent of 2x common, and here we are left with tangent 2x minus 4, that is equals to 0. First thing, to factorize the equation. Now we can say the both factors are equals to 0. Tangent 2x should be equals to 0, and we can say tangent 2x minus 4 should be equals to 0. So from here 2x, okay, now here tangent of 2x is equals to 4. Now we have two equations. The first equation, tangent x equals to 0, or tangent 2x equals to 0, or tangent 2x equals to 4. So 0 to 180 degree, let me draw the coordinate diagram. Okay, so this is 0 degree, this is 90 degree, and here we have 180 degree. So 0 to 180. So if you use the cast rule, C, A, S, and T, here all positive, here sine is positive, here cos is positive, and here tangent is positive. Okay, now it is from 0 to 180. This is 270 degree, and this should be 360 degree, the whole. Okay, now tangent of M angle is positive. So tangent is positive in the first quadrant and in the fourth quadrant. Okay, let me write down the operation for the first quadrant. It is just the base angle. It is 180 degree minus the base angle, and this is 180 degree plus the base angle, and this is 360 degree minus the base angle. BA stands for the base angle, right? Now we need to solve for the base angle in both cases, right? So the base angle here is 2x should be tangent inverse of 0. What is tangent inverse of 0 in degrees? My calculator is in degree mode, right? So let me do tangent inverse of 0, that is 0. So it means 2x is equals to 0, that is my base angle, right? Okay, now what is the base angle over here? The base angle is 2x is tangent inverse of 4. So 2x becomes, what is tangent inverse of 4? 75.96. 75.96 degrees, 0 degrees. Okay, now we have done with the base angles, right? Now from 0 to 180 degree, if you can see, from 0 to 180, tangent is only positive in the first quadrant. Okay, so tangent is positive in the first quadrant. So what is the answer for the first quadrant? This is your base angle. Okay, my bad, I did the mistake here. Hold on a second. It's CAST. It should be tangent, and here should be cos, because A all positive, S sine positive, T means tangent is positive, and C means cos is positive. Okay, now the domain you guys can see is for the variable x, and the angle we have 2x. So what is for 2x? Everything is multiplying x, multiplying by 2 is 2x, 0 times 2 is 0, 180 times 2 is 360. So the domain for 2x is from 0 to 360. Now here tangent is positive, okay, and if we do the exact form, we know that tangent is equals to 0. When the tangent equals to 0, tangent is equals to 0 at 0 degree, at 180 degree, at 360 degree, the tangent values are 0, right? Okay, so we got these are the base angles, right? Okay, now the for 2x, the whole domain we are going to use from 0 to 360 degree, right? Tangent is positive in the first quadrant, and it is positive in the third quadrant, right? So we know that tangent is positive in first and third quadrant. Okay, but from here we have to use the basic knowledge, which we all know, that tangent of theta is equals to 0 at what values it's equals to 0. Tangent of theta equals to 0 at theta equals to 0 degree, at theta equals to 180 degree, at theta equals to 360 degree, and we have so on. Now if we replace, we can say let your theta is basically 2 times x, right? So it means 2x is equals to 0 degree, 180 degree, and 360 degree. So what is your x value? X value is 0 by 2 is 0, 180 by 2 is 90, and 360 by 2 is 180. So these are the three solutions we got um, from the first root. Yes, from the second root, this is we use the concept that tangent is positive in the first and the second quadrant. For the first quadrant, what is the answer for the first quadrant? First quadrant, your angle 2x is equals to your base angle. So what is the base angle? Base angle is 75.96. so here we can say your 2x should be equals to 75.96, and what your x is equals to, which is 75.96 divided by 2. So let me do this on calculator. It divided by 2, which is 37.98. So 37.98, this is 37.98. This is for the first quadrant, right? So now for the next quadrant, we can say tangent is also positive in the third quadrant. So what is your angle? 180 plus the base angle. For third quadrant, your angle should be equals to 180 degree plus the base angle. So this would be my base angle, which is 75.96. So 2x is equals to 180 plus the base angle is 180 plus 75.96. Okay, and then you have 225.96, 255.96. And what x is equals to? X is 255.96 divided by 2, because we have to solve for x, right? For this domain x, it should be lies between 0 to 180. Why I make this domain for 2x? Because the angle, your angles are in 2x, so the domain for 2x is between from 0 to 360, and both the equations are in tangent. Tangent is positive in first and third quadrant. For the first equation, we use a basic knowledge that tangent theta is equals to 0 at 0 degree, at 180 degree, at 360 degree, and so on. So we have to solve for x here. And now tangent is positive in first and third quadrant. So we got the first quadrant, the x value is 37.98, and for the third quadrant, this term divided by 2, and that is 127.98. So 127.98. Now let me write down all the solutions. Okay, we have to solve for the x values. The first is 0 degree, then we have 38 degrees, because 37.98 I rounded to 38. Okay, and I want to round this to 128 degrees. And then we have 90 degree, and then 128 degree, and then 180 degree. So all these are in the range from 0 is less than equals to x is less than equals to 180 degree. All these x values are in this range. So these are the 5 solutions for this equation. Now for part B, solve the equation cosecant of y plus 1.2 equals to 4, where y is in radians and the y is from -5 till +2. Okay, so first we can solve. We know that cosecant theta is the ratio of 1 over sine theta. 1 over sine is cosecant theta. Here we can say 1 over sine of y plus 1.2, that is equals to 4. Now we have to cross multiply. Here we can say 1 over 4 would be equals to sine of y plus 1.2. Okay, so the range of the values for y, that should be in radians, and if we can solve this, if I draw the coordinate axis, we come to know that this is the C, A, S, and T cast rule, all positive, sine positive, tangent is positive, and cos is positive. Here sine is positive, so sine is positive in the first quadrant and in the second quadrant. In the first quadrant we use the operation that the base angle or the principal value of the angle, and here we do pi minus the base angle. Okay, all right, so now we have to first solve for the base angle or the principal value of the angle. So the base angle is y plus 1.2 is sine inverse of 1 by 4. That should be in radians. Okay, now let me calculate it. Your calculator must be in radian. My calculator is in the degree mode. Let me convert it into radian mode. Radian is not number 4. Now my calculator is in the radian mode. Sine inverse of 1 by 4, that is 0.25268, 0.2527. So we can say y plus 1.2 is 0.2527 radians. Okay, now this is my base angle, right? Now sine is positive in first and second quadrant. Okay, so let me do this. Sine is positive in first and second quadrant. Okay, now for the first quadrant we have to use the base angle. For the first quadrant we have only the base angle, so the base angle is y plus 1.2. That should be your angle, the main angle. Here we have y plus 1.2. This main angle is equals to your base angle, which is 0.2527 radians. So what is your y value? 0.2527 minus 1.2. Okay, let me solve this. Minus 1.2, this would be negative 0.97. Okay, y is negative 0.97, and we all know that 0.97 947, sorry, 0.947, 4 and 7. Okay, so 0.947 is in the range from minus 5 till positive 2. Okay, also sine is negative in the second quadrant, so for the second quadrant pi minus that base angle, right? So for the second quadrant we can solve. Here we can say this angle y plus 1.2 would be equals to pi minus the base angle, which is 0.2527. Okay, and y would be equals to pi minus 0.2527, and this subtract 1.2, you will get the angle y. Okay, let me solve this. Pi, take away 0.2527 and take away 1.2. That is 1.688. 1.689 when I round it to. So these are the two values for y. Okay, now we have to write down the journal solutions as well. Okay, now for the journal solution for the sine equation, we have the journal solutions. So the journal solution for the sine equation is now y is equals to negative 0.947 plus 2 pi k, and here we have the general solution y equals to 1.689 plus 2 pi k. So k can be 0, 1, minus 1, 2, minus 2. So k belongs to integers basically. This k belongs to integers. Okay, now let me substitute some k value. So first we can say let k equals to 0. So when you put k equals to 0, you have y equals to 0.947. This is a solution. And when you put k equals to 1, so y would be equals to 0.947 plus 2 pi. Okay, so if I can check this, 0.947 plus 2 and pi, sorry, 0.947 plus 2 pi 7.23. So this is 7.23, but we have the range from -5 till +2. So this is not in the range. So we are not going to add the numbers, like positive numbers. We are not taking the positive numbers. Let's take the negative numbers. So let's take a equals to -1. So to get all the desired solutions, that is why we have to use a journal formula. It is better to use it every time to get all the desired solutions, right? Okay, now for y should be equals to 0.947 and -2 pi. Okay, so if I can subtract it, okay, it's minus 5.5434. Again, -5.34, not in the range. It should be between -5 and 2. This is not in the range. So from here, the only solution we got is this. This is the only solution. Okay. Now let's use a second case. For the second case, again, here we can let k equals to 0. So when k value is equals to 0, you have y equals to 1.689. That is correct. Okay. Now when k is equals to 1, y is equals to 1.689 plus 2 pi. Okay, so let me check. 1.689 plus 2 and pi. 7.797. 7.97 means we are not supposed to add the values. Let's do the subtractions. Now when k equals to -1, so y is equals to 1.689 minus 2k. Okay. Okay, minus negative -4.59. Yes, this is in the range. -4.59. This is in the range of between -5 till 2, because if you take another value k equals to -2, it again -4 pi. Let me check. When you have -4 pi over here, -10 is not in the range. Okay, this is the second desired solution, and this one is the third desired solution. Okay, now let me write down the solutions. Are y equals to, this is negative 0.947, negative 4.59, and positive 1.689. So these are the three solutions which are between -5 and +2. So these are only the three solutions. Okay. Okay, now whenever you have to solve all the desired solution for some trigonometric equations, it is better to first figure out that in which quadrant that trigonometric ratio is positive or negative. If the equation is negative, then we have to solve for the third and the fourth quadrant. Okay, and after that you have to write down the journal solution, right? This thing plus 2k pi and this thing plus 2k pi. This is a journal form for the sine function, right? And then you have to give the values to k, 0, 1, -1, 2, -2, and you will get all the desired solutions which are in the given range. Okay, so that was the last question of our paper. If you have any queries, please let me know in our comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.